This is a very frustrating project. I mean, yeah, I mean, I plug it. It's just like I just don't know what exactly am I finding. Like I'm not too familiar with this stuff. All right, so this is what I came up to.
Okay, so what do you? So, all right, what are you trying to do?
All right, so you told me to. So I got my local maximum and I got my 2 non-derivable points, but I don't have my local minimum. Well, actually, I assume this would be my local minimum since that's at the lowest point.
Yeah, but I mean, do it. It has to be on a curve where it has to be differential.
I don't have a curve.
Right. So it just makes.
How?
Do you know like the equation of a parabola or stuff?
No, it's been a while since I've done that stuff.
Yeah. So normally what I would do like right now, like I would just look it up. But x squared is the equation of a parabola. A parabola. Yeah. And then just whatever.
Come on.
But I mean, if it's not connecting, it's going to tell you. Let's see.
Curve from says to make a parabola.
Yeah. It's going to be x squared. With anything x squared gives you a curve like that. So just make a new function.
Another one?
Yeah.
Well, what about this one? What about this one I have right here that you said?
What do you want to do?
I want to like get a minimum, local minimum curve.
Okay, where do you want to put it?
Starting from right here.
Okay, but then that would take away. Well, no, you can't do that. Okay. All right. So
how would you start?
Write the equation of a parabola. All right. Now, what do you want to do to it? Forget about the other line for a second. And then, what do you want to do to that parabola? Well, before you do the domains, I'd leave it alone. I'd leave it alone so you can see it. Like.
Okay, so now I gotta bring that down.
But the only thing is with your local min, you have to be able to take the limit of the. Well, you can, but I don't know.
Would I have to get rid of this?
Oh yeah, you have to get rid of that. So you have 2 points with a differential.
Yeah.
Local max. You don't have an inflection point. You had the local max and local min before. You just needed an inflection point. Well, now you need it.
You did this last night, so you must have known something about it.
Yeah. Just basically just look at what you need because
Just a local minimum and an inflection point. That's all I need.
you need
And a continuous curve.
All right. So to do a local minimum, I mean, where you can put it anywhere on your graph. It just has to be over here.
I want to do it over here.
Okay, so what do you want to do? Make a local min?
Yeah, I want to know what to do with. How do I turn this and put like curve a local minimum?
How do you?
Like right here. That's what I need to know what to do.
Okay, you have a curve like this. You know how to move it over. You move it left and right by adding or subtracting x, something to x, and you move it up and down. You add or subtract something to only x, so you have to put it in parentheses. So to your x value over here. Wait, delete that. Delete all that. All you have to do is put x in parentheses. Yeah, you see? So it moved it over. Now, like, change the value to 2 or something, and you see, you move it over 2. Change it to 3, it's going to move it over to 3, and so forth. So that moves it over, and then that moves it up and down. So now just, play with your.
Got it.
Yeah.
Yeah, so I got 1 8. Okay,
Yeah.
so we have almost everything. I just need the inflection point.
Yeah.
And that, so this is a continuous curve, right?
Mm-hmm.
Now the inflection point.
Yeah. So, yeah, inflection, you can, the way I use x cubed as an inflection point. So basically, you just need to have the function and then have it connect. So, you can use x cubed if you want. Or really, you just need a function that goes from concave up to concave down.
Yeah.
And if, like, when I didn't know, I just Googled it.
I think always start from right here.
Okay. Well, first just type the function in and then we'll move it. Well, we want it concave. So, in order for it to curve, you're going to have it squared or something. You see? So, alright, you get the base function, the soul of the function, like the core, is going to be x to something. You're just altering the domain right now. Just, you're going to have to raise it to some power. You have to raise x to some power. Alright, 3. If it's even, it's going to be like a parabola. If it's odd, it's going to make that, I guess, an S sideways.
Wouldn't that throw off the whole picture?
Okay, yeah.
If I do it like this.
Yeah, so now that's the base function.
Yeah.
Now we move it over. Where do you want to move it?
-2.
Wait, no. That you're raising and lowering it. Where do you want to move this function?
To left.
Alright, so how do you do that? You adjust x only.
X only.
Yeah. But you have to, see.
Let's try this.
Yeah, that's fine. You can do it. Where those two x's cross. Just define the function. The problem is you have to see what that value is. Alright, now leave it like that and just see where they intersect.
Hang on a second.
Well, you're not going to be able to eyeball it because it's going to be a specific number. So you need to see where they intersect. Okay. Well, the thing is, you don't know if that's the point where they intersect.
Mm-hmm.
It just looks like it. So you have to change the domain.
Yeah.
No, the thing is, we don't know that they're touching right there. Before you do that, you have to see well, if you want to do it from negatives, when x is negative 0.75, you have to see where they intersect. For this part, like right here, for this part, you can't just keep adjusting it. You have to see where they intersect. When this is 0, this is 4.732. So actually, it's at 4.
That's
That's what this value